Everyone, please welcome Lukas Fittl, who will be speaking from PG Analyze, who will be speaking about tracking plan shapes.
Wonderful. All right. Audio looks good. Perfect. I'm excited to see so many people here. Thank you all for making the time. So as Corey mentioned, I'll talk about plan shapes and how we can track them over time, and the new PG-Stat plans extension that I published with some colleagues a couple of weeks ago in its first initial release. Now, there's a couple of things I want to talk about. I want to first talk about what does it even mean tracking plan shapes? Like, what is a plan shape and why do we care? I want to talk about how we can capture plan statistics. So, how can we actually know how often which query plan was used? And then I'll talk about the topic that I spent most of the time on, which is Plan IDs, how we can make them low overhead in terms of calculating a Plan ID for a given plan, and what were the changes in Postgres 18 that actually make it easier now to build extensions like PG-Stat plans that work with Plan IDs. And at the end, I'll give you some details on how the PG-Stat plans extension works. In case any of you have been at PGConf New York City, you might have seen me talk about this before, but in the last part, I have some new things about plan text compression specifically. So there's some new bits, even if you've seen me talk about this a couple of weeks ago. Let's start with saying, the most important thing here, which is query plans can change, and you probably all know about this. But I think it's helpful to just remember, what that means, right? Like we have a query. Sometimes we might have a plan that, looks like this. We get an index scan on a particular index. Sometimes we get an index scan on a different index, right? This is one of my favorite bad query plans, which is you have an order by limit clause, and Postgres decides to use an index on the order by column instead of an index on the where condition. There's reasons why the planner does that. I don't agree with all the reasons why Postgres is doing this, but the point is we want to know when our query performance changes from 0.046 milliseconds to 539 milliseconds, right? Much, much worse, obviously, right? And this can happen without you changing anything. It can just be statistics changing, maybe a different customer ID being input into the query. And so that's why we care about knowing when plans change and plans regress. There's different reasons why that happens, right? And this is not a talk to go into detail on all of these. I'm just pointing out that this will happen, and sometimes you might have made a change that causes it, and sometimes it's maybe the table grew larger, maybe somebody made an index change. Rarely it's Postgres versions. I know people are always worried that plans change in Postgres versions, and it does happen. But personally, I have not seen that a lot. It's usually been other reasons that change plans. And really, the reason we care about statistics and doing this over time is because we can't realistically run explain on every single query, right? If you use the explain command, you get what we just saw earlier, which is what is Postgres doing internally. But if I did this in every single query, I would add a lot of overhead. It would take too much time. And so we're trying to say, how can we do this, but without us, having a tool that does explain on every query. And so one of the key things to think about here is when you're familiar with Postgres and PG-Stat statements, right? PG-Stat statements has this concept of query ID. And the query ID differentiates a query by its query structure. And it chooses to ignore certain things so that similar queries or the same query but different input parameters is actually the same query ID. Now, Plan ID is basically the same idea applied to plan texts, right? So we want to differentiate the plan shape of a plan. So if a plan significantly changes, we want to know about it, and that ID, that 64-bit integer, should change. Now, I think the closest approximation we have to what I would call a plan shape is if you run explain with the costs off option and without analyze. And what this gives you is it ignores, like in the output, it doesn't show you the costs. It doesn't show you any execution statistics, right? Because it's just asking Postgres, what is the query plan that you're going to use? But it does include key information like, are we doing a sequential scan? Are we doing an index scan? What are we aggregating? Things like that. And so this is, I think actually when I talk with people, most people agree that this is a reasonable definition, right? And basically what I want to do, what I think is the right thing to do, is say a plan ID is kind of like a hash of this, ignoring some more things, right? So for example, here we have an email that we're searching for, and we don't want to have a different plan ID if we search for two different emails. We only want to have a different plan ID if it changes the type of the notes, for example. And so this is just an example of what we can do with this kind of information is we can actually visualize, how often does plan A happen versus plan B happen? Is plan A slower than plan B? Things like that, and we can do that over time, right? So this is just a simple visualization of some of the things we'll see later, but just to point out that's the motivation for doing this. I want to be able to visualize it like this. And this is a quote that I found a couple of months ago when I first prepared the first version of these slides. Where back in 2021, somebody was saying, basically they're a huge fan of Postgres, but they were pretty frustrated with something in Postgres. And the frustration was basically they, think it's a user error, but they were still hit pretty hard. They still had a pretty bad experience because the query plan suddenly changed on a frequently run query. Query was running 1,000 times per second. It was a large table. And so suddenly that query that was running so often changed from sub-millisecond to multi-second. Right? And you can imagine the pain that brings to a production database. And so then they kind of concluded, the query planner is pretty good, but it's also opaque. And so I don't agree on the opaqueness necessarily, but I do think that this perception of things being opaque and not knowing what's going on really is a lack of observability, right? Like we don't know what the database is doing. This is not a new idea. So some of you might remember there was an extension called PGStatPlans many years ago. Back in 2012, Peter Gagan and some other folks back then at Second Quadrant worked on that extension, and it basically tried to do the same thing, which is capture plan statistics over time. Unfortunately, that extension is not maintained anymore. I think the last commit was many, many years ago, and the commit basically just said, this is unmaintained. And so you shouldn't use that one. There are other alternatives. So there's PG Store Plans, which has been around for a couple of years, but that one has high overhead. And I'll speak more about how we can reduce the overhead, but basically I wouldn't use PG Store Plans in production because unfortunately the way it does things means you have in some edge cases 20% overhead if you enable that extension. PGStat Monitor is another extension that optionally can collect plan statistics, and only if you enable that option, it also has high overhead because of the way it calculates the plan ID. Now, there was one key thing that made me think we can do better here, which is AWS actually launched something for Aurora called Aurora Plan Stats. And Aurora Plan Stats tries to do plan statistics and actually does it reasonably well. And if you are in a recent Aurora version, you can just use this out of the box. And so if you're on Aurora, problem is solved. You don't need any of the stuff we're talking about here. But the problem is many of us are not in Aurora. The extension is not open source, right? So we can't actually use it in many environments. Microsoft also has something in Query Store. Query Store is also closed source, so don't know how that works. Haven't tested it much. But really, the point is I want to have something that works better in Postgres, right? I want to have something that we all can rely on, that we all can use. Maybe not this iteration, right? Like it's always, it's an invitation to discuss how we can do better here. So one of the challenges, right, is we want to calculate this plan ID. And the problem with this plan ID calculation is it must happen extremely fast because you're doing this as queries are executing. Right, because as queries are being planned, actually. So, query plan is finished, right, and you have a plan that Postgres is going to use, and you want to, at this point, assign a plan ID to be able to then accumulate statistics about it. And so whatever we do, it needs to be fast enough. And so the problem is these existing extensions, the way that they've done, but I guess I don't know about PGStatPlans, the original one, but definitely PG Store Plans and PGStat Monitor, the way that they've implemented is they basically run explain print plan, which is the internal function in Postgres that implements the explain command, and then they hash the output, which you can imagine if I have a really fast query, this actually can make things slow, right? Because I'm suddenly producing a big string, I'm running a hash function on that string, and so whatever we do, we can't really do that, right? Like that doesn't seem like the right direction. And so what PGStat statements has done, and nowadays Postgres does in core, is what's called query jumbling. And jumbling is kind of an awkward word for saying hashing. So if you see jumble, just think hash, in my interpretation. And so a query ID, really, what it does is it looks at the query struct in Postgres and the query post-parse analysis tree, and just walks through it. It builds an internal accumulation of stuff, and then it calls a hash function on it. And so we're trying to do the same thing. We're trying to do that for plans. And the reason that's different from running the explain output through a hash function is it's much smaller, right? Like we don't, node IDs become an integer instead of a text. Expressions, are much more compact, right? So like the overhead of hashing it is much lower. Now, this is not trivial. So there is a reason why PG Store Plans and PG Step Monitor and other have not done this, because we have many different node types in Postgres, right? Like internally in Postgres, like index scans, for example, they are a kind of scan. They have an index that they're scanning, but then they also have index quals, like in the index condition basically on that index. And the problem is that you have like 300 plus node types that can appear in those expressions, right? Like these quals. And so here, for example, that source code comment says, usually index quals are op expressions, right? Like operator, like equality comparisons. But they can be anything, basically, like any typical expression node. And so if we were to maintain our own custom logic for, hashing that, it quickly becomes very hard to maintain, right? Like if you do it manually. Now, in core Postgres, and this might be, for those of you who haven't looked at the Postgres source, I apologize for, including too many examples of source code, but again, we have these node structs, right? We have these different either expression nodes or plan nodes. We're trying to say which of these are significant, right? Like if I'm calculating a hash, which of those should I actually care about? And so I think whatever solution you do, in order to be maintainable, you should maintain it on these node structs, because as if I want to say Postgres 14, there's this concept called node attributes. So maybe a little bit hard to read, but basically here we're looking at a memwise plan node, and the memwise plan node has a number of estimated entries, and we're saying PG node attr, ignore this when jumbling, right? Ignore this when we're hashing. And so this is something that has been implemented for the query ID calculations in order to make sure that the query ID calculations are maintainable. And so this is the same idea, but for plans, right? For plan nodes. Now, in Postgres 18, I tried to first propose that we should just, do all of this upstream, right? Like, I think the best solution is if Postgres just did that and calculated a plan ID for us, so that we could just rely on this and we could build tools and extensions on it. And so if in the Postgres wiki, if you search for plan ID jumbling, you'll find a wiki page that I authored early this year, and you'll find basically, what I think is a good idea basically for which things are significant and which things are not significant. The reason I made a wiki page is because I think we need to agree on this to actually have, an upstream Postgres definition of a plan ID. This is a call to action. If anybody is interested in this, please look at the wiki page. Please, comment on the existing hacker thread, because we have not seen enough interest to really move this forward as an upstream definition of what a plan ID is, right? So first of all, those changes did not get into 18. I'll get into a moment on what did get into 18. Another thing that's nice about doing this completely in core is we have an existing tree walk that the planner is doing. So at the very end of a planning cycle, there's a part in the file called setrefs.c where it basically looks at all the plan nodes. And so because we already walk all the plan nodes, we could just easily calculate a hash, right? So that would be less overhead than doing a second tree walk. And so most of these changes, unfortunately, did not get into Postgres 18. That's how Postgres development works, right? So it's always good to have patience when you try to improve stuff in Postgres. But we did get a key improvement in 18 that we can build on, and we being extension authors, really, which is the ability to set a plan identifier or plan ID on the plan statement struct, right? So plan statement is kind of the output of the planner. And so plan statement now has, in addition to the query ID that it already had before from the query struct, it now has that plan ID. And so in Postgres, if you're writing an extension, you can now set a plan ID, right? So you can write your own planner hook, you can do your own tree walk, you can do stuff to basically assign these plan IDs, and then you can build something out of it. I'll come back to that in a moment. It does enable a key feature of the PG Step Plans extension that is not possible without that change in Postgres. There's one other thing that Postgres 18 added, which is, I think, really exciting, also quite complicated. So I won't get into the details of it right now. But basically, this is a commit that Michael Poquier and some other folks worked on around introducing a pluggable API for cumulative statistics, right? So Postgres has this shared memory cumulative stats system And that basically tracks, pgstat user tables and some other things. And so the idea is that we can, use that same stat system for extensions. So you can now, in Postgres 18, write an extension that uses Postgres' built-in mechanism for tracking statistics. One of the key things that this helps you do is it reduces overhead. Like you have different connections in Postgres calculating stuff, and what the cumulative stats system does well is it can aggregate those stats at the right points in time. Like a transaction commits, it can add up stuff into a shared memory state. And so that is now possible as an external extension as of Postgres 18. Now, let's spend a few more minutes talking about pgstat_plans. So first of all, if you want to look at the code and give me feedback, please, find the GitHub repo here, right? So it's under our PGAnalyze org. But this is, Postgres licensed. Like I want this to be widely used and widely changed. The goal here is to find something that's useful for everybody. And so pgstat_plans is now released. To differentiate it from the original pgstat_plans, I made 2.0, right? Because this is a very different code base than pgstat_plans 1.0, which was the second quadrant project. But this is, I think, the best name for it. So, I think this is tracking plan statistics, so it should be called pgstat_plans. Now, one of the key things that, like the whole point of talking about overhead, right, is like it actually is faster. A little bit hard to read here, but basically what we're seeing here is a benchmark on a sizable AWS instance, and it's basically testing, pgbench, and it's saying, Postgres 17 with pg store plans, Postgres 18, and then Postgres 18 with stat statements, and Postgres 18 with stat statements and pgstat_plans. More is better, right? And it's a very simple workload. But basically, what we're trying to avoid is that dip that you see between the first bar and the second bar, right? Like the first bar is faster, the second bar is slower, because store plans, for example, has too much overhead. And so with pgstat_plans, we're basically seeing, really it's the third bar. Let me see if I can point to that. It's really this one here, right? That's like the no extensions loaded perspective. This one here is just pgstat_plans. And this here, I think, is pgstat statements plus pgstat_plans. And the reason that pgstat statements has more overhead is because of some of the internal locking stuff that stat statements doesn't do so well today. But the point is, you can safely use this on production in terms of overhead, right? Like this actually is like less overhead than pgstat statements. But you do usually need pgstat statements. So to be clear, I would recommend using stat statements and pgstat_plans. All right. So what does it actually give us? So if we look at, just select star from pgstat_plans, I get, something very similar to pgstat statements. So I get, let me see where my pointer is. There we go. So I got a user ID, a DB ID, top level, right? Like if it's in a function or not. The query ID, this is the existing logic, and then really the plan ID is the key part. And I see how often this plan ID was called, how much time we took to call, and then the plan text. This is, again, that explain costs of text. The way that the plan ID calculation is done here is we're doing a tree walk, but we're doing it by copying a bunch of code from Postgres because the Chambl functions are not accessible to an extension, so we had to copy that out. And then I think the piece that is really exciting and requires Postgres 18 is what we call pgstat_plans activity. And so what this one does is it's not finished statements, it is statements currently running and which query plan they're using. So we see here, a given PID, if the pointer, well, there's a pointer. We see a given PID, right, and we see which plan ID was being used, and then we see the plan text for that particular PID. And what this lets you detect, right, is like if I have a slow query, like my query suddenly became slow, like that example that I referenced earlier, and they're not finished yet, and I'm trying to understand, well, did the plan change? Now with this view, I can actually get the current plan being used for currently running queries. And so this relies on that internal plan ID because you have to have a way of tracking it. But now with this, you can just query the currently running plan. Important note here, some people ask, does this collect statistics about, how far along is the execution? And the answer is no, right? Like this does not track any execution statistics. Like we don't know, is this merge join, half finished or is it just starting? Like that is much more complex to make work well. This is really just trying to say what is the plan shape of that query. Now, last, I want to talk about something that's actually a little bit of a challenge here, and this is a challenge of PG stat statements as well, which is where do you store this text, right? Because when we talk about the stat subsystem, it stores counters, it stores integers, it's very small. Here in this case, we need to store this text somewhere. And so one choice that I made here, based on also some discussions in the community around what we want to do for PG-stat statements in the future. And so I figured, for PG-stat plans, let's try something new. For context, PG-stat statements stores in the file. That can have problems. And so here, we're actually storing the plan text in dynamic shared memory. So that means that for whichever statements, information, whichever plans we're keeping around, we basically keep the plan text in memory. Now, we don't want to do this for everything, right? So by default, we actually take only 10 megabytes of RAM to store plain text, very little memory, because we want to make sure that this is not a problem on its own. But the benefit is it's much faster to store entries, and it's much faster to load entries because you don't have a file involved in that. Now, one of the more recent things that I did here is work a little bit more on compression, because if you store a large text, like this is an actual example of an explain output. This is an explain costs of output. It's 4,700 bytes, which is not a lot in today's disk space, but it is a problem when you store it in memory. So if we just store this really large plan 2,000 times, we exhausted our 10 megabyte shared memory allocation, right? And so when we compress it, that gets much better. So if we compress this text with C standard, we get a compression of 4,700 to 855, so about 20% of the original size, and that's pretty simple in a sense. And then the other experiment that I did recently is I added a dictionary to that, so that we actually C standard isn't great when things are small, right? Because it doesn't have a lot of context, and so it can't compress that well. And the C standard has this feature where you can give it a dictionary, train it on typical data, and then it gets much better compression ratios for small kind of files or small texts. And so in the best case here, basically, with that dictionary, we get 17,000 entries of that size, of that big plan size, basically, in 10 megabytes of shared memory, right? So this, I think, is acceptable, basically. This is, for PG-stat statements, for example, 5,000 is the typical entry limit. I think for PG-stat plans, 5,000 is also a reasonable limit, right? And so we can store large plans as well. This is probably hard to read here. I already posted the slides on the PGConf schedule, so if you want to look at this, feel free to look there. But the point is just, this was a more thorough comparison of a couple of sizes where this is a 16 kilobyte dictionary, basically. And you can see the one thing I want to point out here is if we don't use a dictionary with C standard, if we have an original plain text that's very small, 50 bytes, it actually becomes larger in some cases because compression actually makes it worse, basically. We may just not want to compress in that case. But if we do compress with a dictionary, then we still get a little bit of a benefit there, right? So the dictionary really does help, reduce, here in this case, 64% average size, right, compared to the original, without a dictionary, and then 37% of size with the dictionary. So it definitely helps to use the dictionary if we can. All right, a couple of things that I'm still working on here that I'd love to, again, get input on, get people to contribute if you're interested. So some of these text compression improvements are not yet in the main repo. I have them locally as a branch, like the dictionary work. So I want to stabilize that, make sure that that works as expected. Get that into a released version. I do want more people to do testing and benchmarking. So if you want to give this a try, please do. Please, post crash reports with backtraces, whatever makes sense for you, because I think that's how we get to a stable extension. I think it's in a reasonable shape now, but I wouldn't put it on a big production system yet, right? I would put it in a staging system, a QA system, and test it there. For those of you in the room who maintain the Debian or Red Hat packages for Postgres, I'd love to get this in the Postgres repositories. And also for those of you who are either a customer of a cloud provider or you work at a cloud provider's team, I'd love to talk about what it takes to get the extension into different environments. And then 3 last open questions, and then we'll have a little bit of time for Q&A. Things that I've been thinking about, and there's not yet a decisive answer to. Should we special case table partitioning, right? If a plan only differs based on plan time partition pruning, is that the same plan shape or is it different plan shapes? One thing I've realized in my own testing is that you just get a lot of unique plan IDs, plan shapes, if you don't do something about this. should we normalize plan text, right? So if a plan text has an index condition and it has a specific filter value, we ignore it in the plan ID calculation, but we don't currently normalize it like stat statements, like if you say value equals, like column equals some value, stat statements actually replaces it with a $1, $2. Question, should we do the same in a plan text? Should we teach explain C to do that for us? And then last, there is a question about what we do about auto-explain. Right? So auto-explain exists today in Postgres. Auto-explain is good for sampling, but it does use the logs, and it's inconvenient to have to go through logs. And we could argue that something like pgstat plans should include a sampling feature to actually collect plans with analyze on for those who want to collect them. So something that I don't have good answers to yet, but I'd love to talk to you in the hallway or by email. And yeah. That's basically it. Send me an email at lukas@pganalyst.com if you're interested in talking more about these things. Here's the QR code for talk feedback, so if you like this talk, please give feedback there.
We have time for a few questions.
Thanks, great talk. 2 quick questions. So I don't know exactly how this pluggable stats stuff works, but if you shut down Postgres, I guess it gets serialized and you don't lose it? Or is it just in dynamic shared memory and gone after?
So you can opt into that serialization. So if you write an extension, you can now say that you want to also be written out to disk on shutdown. In pgstat plans, we don't do that right now because the plan texts are managed separately, and so we'd have to invent our own mechanism for writing out the texts separately from the counters. There is a proposal for Postgres 19 to improve on that as of last week. So right now, basically, we don't do it here because it's hard to do well, but in Postgres 19, that should be really easy.
And quick second question, did you consider truncating the plan at a couple thousand characters or something in order to get more in? Because there can be really huge plans, I guess, and then you would just blow away everything.
Yeah, we definitely, there is actually built-in, there's a built-in maximum, and we truncated that. So you can configure it, but definitely there is a maximum, even if compression, can't compress it well enough.
Do you support other plan formats like JSON?
Good question. Not right now, and as somebody who likes to have machine-readable plans, I say it with a sad smiley face. The problem is you, again, make the plan text larger, right? So you kind of, you're making your life harder by having all the JSON stuff. Maybe with C standard dictionaries, it might be okay. But yeah, the reason why it's not there right now is because it's too big, basically. Easy to add, though.
Thank you for the talk. Short question, what about backwards compatibility for older versions?
Yeah, good question. So the Postgres 18 edition of Plan ID, you can't, you could backpatch it, but an extension can't do anything about it because it's just missing. But we did actually end up adding support for Postgres 16 and 17 to pgstat plans by basically doing some things differently. So pgstat plans as released today supports 16, 17, and 18, but only on 18 you get the full feature set. 16 and 17 you get a little bit less features.
We have time for one more very concise question.
So in the quote on the first slide or something, you had the complaint that people were saying that the plans change without warning. Mm-hmm. Is there anything in there that will tell you how close you are to flipping the plan or fixing that warning part?
I think, yeah, good question. There's nothing built in here. I think this is a step towards that. You could build a tool that monitors it, but it would have to actually happen, right? Although getting a plan for a currently running query gets you, in that moment where it starts happening, you can know it right away. So I think it reduces the response time, but it doesn't tell you when you're almost flipping. Awesome. Right. Well, thank you, everybody.
Thank you.